polynomials. Our essential question is, what are some ways to factor a polynomial, and how is factoring useful? So what are some ways that you can factor a polynomial? Greatest common factor. That's what you were, that common monomial, that's the same thing. Okay, so greatest common factor, which is also a common monomial. Is there another way that we factor?
GCF, no, not it, right?
Difference of two squares. By now, you know, there was a time when I probably would have just given a quiz on difference of two squares, because y'all should be able to know those very, very quickly. Remember, you're looking for a square and a square. There's always a minus in between. So if I have x squared minus 16, boom. I know x plus 4, x minus 4. Why do you think factoring is useful?
Let's break down the problem.
Break down the problem? Why do we need to break down the problem?
So it's easier to solve? So it's easier to solve? Or?
Makes it easier to solve?
Makes,
Easier to look at?
yeah, let's say makes it less big.
Makes
Okay.
it less big.
Makes it less big.
What happens when we break it down into those smaller pieces? What can we find easily?
Our x and our y's.
Those x-intercepts, which are our roots, which are our solutions. That's why we want to factor these. So, let's look at the first one. Factoring out the greatest common monomial first. That's your GCF. Y'all been doing this forever. This is not always possible. Did you know that? To factor out a greatest common factor. Right? Okay.
Sometimes.
When a factor of degree 2 or greater cannot be factored any further, it may be recognized as being irreducible. So, let's look at this one that they give us. Don't ask me why they say write out the polynomial. It's already written out, so you typically would not have to rewrite it. But it says factor out the common term first. The only thing they all have in common is an x, but what else do they have in common? A 3, and I would probably write that first. They broke it down separately, x and then a 3. But if I divide, because y'all, that's what factoring really is dividing. And we've already done adding, subtracting, and multiplying. Now we're going to divide. So if I take 6 and divide it by 3, I get 2. If I take x squared and divide it by x, oh, this is a cube. Sorry about that. If I take x cubed and divide it by x, I get x squared. That's all you're doing. You can always check yourself and multiply this back, and you should get this original term. Then I have to look at this second one, and I have to factor it again. Now, that cannot be factored any lower. What are your zeros here?
Ooh, x.
Pause. How many zeros will you have in this one?
3. No, 2.
You already forgotten that?
No, 2. 2.
You look for that leading exponent, the highest exponent. That's the number of zeros you're going to have. So, what are my zeros? I can find them here. That's when
3.
you say, okay.
3.
All your x's.
Remember, we're setting this equal to 0. So if 3x is equal to 0, what is x?
0.
0. So that's one of them.
Told you.
2x plus 1 is equal to 0. Okay? X is equal to -1/2. That's another 0. then x plus 2 is equal to 0. What is that one? Okay, I found these. What does that mean to y'all?
For all your x's.
All my x-intercepts, I have one here, and one here. Great. Now what can I do?
You can use it in your problem. You can plug it in.
What if I said, I want you to graph from your zeros?
It's better than
Great,
not
I've
answering
graphed them. Think back what we've already learned. Is this an even or odd function?
Oh,
Odd. So is it going to end in the same direction or different directions?
different.
Different. Where is it, positive or negative? So where is it going to start? Down or up? Down. So that means it's going to be going up here. Do I know exactly where everything else is happening? No. That's how you can graph from what we just did. Okay, let's look at B. It says write out the polynomial, which again, we've already done, but we're going to do it like, because that's what they're asking. Factor out the greatest factor, the greatest common factor. So, do they both have a 2 in them? Yes. Do they both have at least an x? Yes. And then I'm left with x squared minus 10. The question is, why isn't this further factorable? Is 10 what?
One right and four.
Ah, is 10 irreducible? This whole thing is irreducible. Is this the difference of squares?
Yeah. Well, no.
No, it's not. So I can't just easily factor that. That's why we're saying, okay, we stop. Can't factor it any lower. That's as low as this one can be factored. Let's see, what does this say? Consider what happens when you factor that. We're gonna skip that because we're not getting into that information. All right, let's do this one. 3x cubed plus 7x squared plus 4x. Factor that as low as you can get it. Can that be factored any lower? Did you try it? Okay. So if we did try it, we would have what? X squared plus 7x plus 12? Remember slide and divide? Can this be factored?
12.
Do I have two numbers that multiply to give me 12 that add to give me 7?
4 times 3.
4 and 3? Okay, so let's try that. Well, let's see. Okay, so we still have x, and then we have x plus 3, x plus 4. But remember, I multiplied by 3, so I have to divide by 3. I'm left with x times x plus 1 and 3x plus 4. So could I still reduce that further? Yes. So that's when you have to remember to do your slide and divide to see if you can factor it. Any questions on factoring out just your greatest common factor? Don't stop there. You have to take it further. Up here, we couldn't take that any further because it can't be factored, but here we could. So you have to do a little exploring on that to see. Do what's next.
Two large heads are in the way.
Okay, Isaac, would you stop that one?
Yes, ma'am.